Ocean rocks and sediments. So in addition to making maps, sediment and rock samples were also collected as we were mapping the ocean floor and collecting all this data. The ages of rocks vary on a predictable pattern across the ocean floor. So we have this predictable pattern of ages for these rocks. And what is that pattern? So rock samples taken near the ridges are younger than those taken near the trenches. So if you have your ridge here, come over, we have a trench here. These are young. These are old. Okay, and so let's move this way. So you have younger rocks near the ridges, and then the rocks get progressively older as you move away from the ridges. So they are youngest near the ridge, and then they get progressively older as you go away from the ridge. Okay. It's also symmetrical on either side of the ridge. So if they are young in the middle and they are old on the edges, and then if you go about the same distance on either side of the ridge, you get about the same age of rocks. So if we went about here and we found something that was 50 million years old, we'd come out about here and we'd find something about 50 million years old. Okay, so it's symmetrical on either side of the ridge. And then even the oldest rock samples from the seafloor are geologically young at about 180 million years old. So the seafloor is not nearly as old as everybody thought it was. They thought it was ancient compared to the continental crust. Well, the oldest rocks in the ocean were about 180 million years old. Continental rocks are much younger, which some of those are as old as 4 billion years. So some of the rocks that we found on the continents are as old as the planet, pretty much. So they've kind of been here since very early on. But the oceanic crust, again, is relatively young. So sediments, so ocean floor sediments are typically a few hundred meters thick, whereas large areas of continents have sedimentary rocks that can be up to 20 kilometers thick. So we have a few hundred meters of sediments being silt and sand and clay and stuff that would fall and make a layer of fine particles. But on the ocean floor, we have sediments that are a few hundred meters thick. But if we got on the continents, we can have areas of rocks, sedimentary rocks, that are 20 kilometers thick. So the difference in sediment thickness was puzzling. So the leading hypothesis was that the ocean sediments were thinner because the oceanic crust was younger. So if you have less time for sediments to deposit, then they're going to be thinner. It's like if you have something that sits still for a long time, you get a big layer of dust on it. If it hasn't been sitting there very long, you won't have as much dust. Okay, so you can kind of tell how long something's been sitting still by the layer of dust on it. Well, same thing with the ocean floor. The ocean floor has less sediment because it's not been there as long. Then ocean sediments are thinner near the ridges and thicker near the continents and trenches. So basically, again, we have the ridge in the middle. And as you go out from the ridge, these sediments get thicker and thicker. They're thinner near the ridge. This is also symmetrical on either side of the ocean ridge. So we came out on this side there, we get thicker as we went away from the ridge. Okay, so we got this symmetry again. Now, ocean rocks and sediments. So we basically, this is sort of a diagram of all this. And we have basically our ridge here. Okay, so the ridge is running through here. Then we have younger rocks near the ridge. Okay, so we've got our younger rocks sitting here near the ridge. They get older as you get further away, so our older rocks are over here. As far as sediments go, we got thinner sediments near the ridge, and as we get further away, we got these thicker sediments. And again, this is symmetrical, so if you have thin sediments over here, you got thin sediments over here. If I have younger rocks here, I've got younger rocks here.